Now the topic that we are going to cover is context-free grammar equivalent to regular expression. Context-free grammar equivalent to regular expression. So how to get a context-free grammar regarding equivalent to regular expression. So first of all, what do you mean by the regular expression? So suppose one string is given to me, like any string ending with 0. Any string ending with 0. So this is the example given to me, any string ending with 0. Now for that, if I want to make the regular expression, then what I should do? That it is going to end with 0 always. So I can take ending will always be 0. Now in front of the 0, there can be either 1 or 0. Now the string is containing 2 alphabets only, that is 0 and 1. It is containing only 2 alphabets, that is 0 and 1. So I am taking the alphabet 0 and 1, and for that the example is that any string which is ending with 0. So 0 is the ending, but in front of that there can be 2 alphabet, either 0 or 1. So now it can be like, we can take the example of that string 0, then 1 0 is also ending with 0, 0 0 is also ending with 0, 0 0 is also ending with 0, 1 0 0 ending with 0, 0 1 0 ending with 0. So infinite examples we can take. Now in this we can find a common pattern, that every string which is ending with 0 only, ending with 0 only. Now in front of 0 there can be either 0, see here there is nothing, so null is there. Now in front of 0 there can be null or 1 or 0 or combination of 1 and 0 both. So from that, if we are said to make regular expression, then what should we do? That ending is always 0, so we'll have to take ending is 0. Now in front of that, null can be there, 1 can be there, and 0 can be there. Now null is there, 1 is there, 0 is there, and occurrence of an 1 and 0 can be there. So we can take either 0 or 1 can be there in front of my 0. It can occur multiple time. Now there can be also null in front of 0. So we can take here star. So 0 plus 1 star 0 is a regular expression for any string ending with 0. So suppose nothing is being occurred from this, so null is occurring, 0 is there, so 0 is my string. Now from this 1 is occurring, 0 is there, so 1 0. Now from this 0 is occurring, then 1 is occurring, then 0 is occurring, then 0. So 0 1 0 0. So in these examples we can see there is a common pattern, that my strings are always ending with 0 only. So that's what I wanted to find, that any string ending with 0. So in this way we can make the regular expression. Now this is my regular expression, that 0 plus 1 star 0. So this is my regular expression. Now from this I want to make context free grammar. So the context free grammar equivalent to regular expression I'll have to make. So we'll have to start with starting symbol. So suppose I am taking starting symbol S. Now here the example is given to me, which is, the example is 0 plus 1 star 0. So here if I am considering these two as two separate expressions, so suppose if I am considering this as A and this as B, so what I can take, that from starting symbol I am getting A and B. So here I can take from S, I am getting A followed by B, A followed by B. Now for individual A and B, I'll have to make the production rule. So here we can think like A contains 0 plus 1 star. A contains 0 plus 1 star. So A is containing occurrence of 0 or 1 or null can be there. A is containing occurrence of 0 or 1 or null can be there. So we can consider recursively A is containing 0 or 1, 0 or 1, and at the end if we don't want anything then we can take null as well. So here we can consider that this is my A. So from A I am getting A0 or A1. Now it is containing 0 and 1's occurrence. So that's why I have taken from A I am getting A0, A1. So continuously I can take 0 or 1 whatever I want. But 0 plus 1 star is there. 0 plus 1 star is there. So it can contain null as well. It can contain null as well. So A can contain null as well. Now the second statement we are considering B. So what is B? Now B is containing 0 only. B is containing 0 only. So for B we can write it as B is deriving 0. B is deriving 0. Now this is my context free grammar for this production rules I have defined. Now from this if I want to derive any string, from this I want to derive any string. These are my production rule, and from that I want to derive any string. Suppose I want to derive a string which is satisfying this regular expression. So I can take the string which is ending with 0. So suppose I am taking 0, 1, 0. This is my example. 0, 1, 0 is my string. Now I want to get this string using these rules. So how to get it? So initially I can take from S. I am getting A and B. A and B. Now here in the example A is deriving either 0 or 1 or null, and B is deriving 0. So B will always be 0. So my string is always ending with 0. So here my example is 0, 1, 0. So now in that I can consider 0, this as B and this as E. Now these two are different terms. Now 0, 1 I'll have to derive using this production rule, and 0 separately I'll have to derive. Okay. So first of all we'll start with starting symbol. So here I'm taking starting symbol as. Now from that I'm taking A as well as B. Now from A I want to derive 0 and 1. So initially if I'm considering this second production rule, from A I'm getting A0 or A1 or null. Now from A I want to derive 0, 1. So 1 is ending, so I can take second term which is A1. So here I'm going to take from A I will take A1. From A I will take A1, and B is as it is. Now 1 is achieved. Now next I want to get is 0. So from A I can get 0. Yeah, the first statement A0 is there. Over there I can get A0. So here from A again I can get A0. Now 1 as it is, B as it is. So 0, 1 is achieved. 0, 1 is achieved. 0, 1 I wanted to get, but 0 and 1 in front of them A is there before 0. So we'll have to remove A, and if we want to remove A has to be null. So from A any term is there which is deriving null. Yeah, the third statement exists which is deriving null. So now A will become null. A will become null. 0 is there, 1 is there. Now null 0, 1 itself it is 0, 1. Now the next term is B. Now from B what we can derive? So from B we can derive 0. So 0 is derived here. So ultimately at the end we'll get null 0, 1, 0. That means 0, 1, 0. Now 0, 1, 0 is the string we got using this test. That is what we actually wanted to get. So yeah, this string is achieved using this production rules. So we can use this production rule, which is equivalent to this regular expression. So this was our regular expression. So first of all, we'll have to separate in two parts, and based on the individual part, if it is being recursively called, we can make the production rule. So from B I am getting 0, so I have taken from B I am getting 0. From A I am getting either 0 or 1 or combination of 0 1, which is recursive. So I have taken from A I am getting A0 or A1. So continuously I can call A0 A1. Recursively it is being called. Now it is also containing occurrence of that, which can be null also. So that's why I have taken from A I am getting null. So S is containing two terms. First is A, second is B. Now A and B is there. B is followed by A. Now A is containing occurrence of 0 as well as 1, as well as it can be null. So I have taken A0, A1 and null. Now B is always 0. Why? Because our string is always ending with 0. So I have taken B. From B I am getting 0. Now here was the example that this string I want to get. So I have taken the example from S. I am getting A as well as B. Now from A I have taken A1. So I am getting A1. So yeah, 1 is achieved. Now next 0 I want to achieve. So I have taken A0. A0 was the derivation. So yeah, I got A0. Now 0 1 I wanted to get. Yeah, 0 1 I got. Now A has to be null because I just want 0 and 1 only. Now at the end the term of B will come. So B from B we want to derive 0. So from B 0 is there. So from B we will write 0. So at the end we are getting null 0 1 0. That means 0 1 0. So that was our string we wanted to get in, and now at the end we got it. Now the next example which is given to me, which is language L, where X belongs to 0 1 whole star, means my string is containing occurrence of 0 as well as 1 as well as here we'll have to take that number of 0 is greater than number of 1. Number of 0 is greater than number of 1s. So this is our language which is given to us. That language L is there, where X is my string, which can be occurrence of 0 as well as 1. Now over there the number of 0 has to be greater than number of 1s. So what can be the example for this? So here we can take the example 0. So yeah, 0 is there. Now 1 is not there. So obviously 0 is 1 time, 1 is 0 time. So number of 0 is greater. Now suppose we are taking example of another 1 0. So 1 0 over there both are equal. So this is not possible string for my language. Why? Because number of 0 has to be greater than number of 1s. So here number of 0 has to be more. So we can take 1 0 0. Now 1 0 0 is there. Now we can take 0 1 0. Now again we can take 0 0 1. So there is a possibility that only 0 can be there. Then 1 0 0 can be there. 0 1 0 can be there. 0 0 1 can be there. So if 0 is 2 time occurring and 1 is 1 time occurring, then these 3 possibilities can be there. Now so on we can make that 4 times 0, 2 times 1. Now 4 times 0 and 2 times 1. So the position of 0 and 1 can differ, but it will be according like this only. So if we are going to take the context free grammar for this, then now here if we are making the context free grammar for this, production rules will have to take. So initially I am taking a starting symbol. Now this is 1 time 0 is there, then 2 times 0, 1 time 1 is there, but suppose 2 times 0 is there, so we can take like 0 0. Now 0 0, so possibility of 1 is not there, so 0 0 can be there. So here we can take the example that only 0 can occur. So yeah, we can take only 0. From S we can take only 0. Now if 2 times 0 is occurring, so we can take from S0 or 0s. So yeah, 0 can occur in any manner. So from S, if we are taking 1 times 0, again I am taking 0. So 0, 0, 0, 0. In both way it can occur. Now for the above example, that 1, 0, 0, 0, 1, 0, 0, 0, 1, 0. Okay. So if you want to take this example, then 1 is there. So we'll have to consider 1. Now over there 2 zeros are there. So if we want to take 2 zeros, so suppose we are taking this production from S, I am getting single 0. So if I want to get 2 times 0, I'll have to put double S. Now if the sequence is getting changed, so for 0 I'll have to take S, then 0, 1, 0. So 0, 1, 0. So S, 1, S. Then next example is 0, 0, 1. So for 0 S is there, for 0 S is there, then for 1. Okay. So here we can take S as 1. So now recursively we can call this, and we can take the combination of single 0, double 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. So in this way we can take multiple examples. Now whenever the number of 0 will get increased, number of 1 can also get increased, but it has to be lesser. So this works for 2 times, but as we have called it recursively, the number will get double and the ratio will get maintained, that number of 0 will always be greater than number of 1s. Now if we are using this production rules, and using this production rules we want to derive some strings. So suppose if I am taking the example of a string which is 1, 0, 1, double 0. Now this is my string which I want to get derived from this production rules. Okay, so first of all what I'll have to do, I'll have to start with the starting symbol. So from starting symbol I can derive any string. So now here we can take that what is the starting that I want to get. So in starting I want to get 1. So in starting, is there anything which is containing 1? Yeah, so fourth production rule, that is 1 as S. So I can take here 1 as S. Now 1 I got and 1 is there. Now the second one that I want to derive is 0. So from S we'll have to derive the next thing. So single 0 is possible. Yeah, single 0 I can derive. So here I'm taking single 0. So 1 as it is. Now here from S I am deriving single 0. So second this production rule I have taken. Now the turn of the third S. So here in the third statement we want to derive 1. So what is the statement which is containing 1? So here the statement, the fourth number again 1 SS is there. So here I can take the example that S was already there. Now from S I'll have to derive something. So 1 as S. Now 1 and 0 same as it is, as it has been already derived. So 1 0 is already there, 1 as S is there. Now 1 as S I have derived, so 1 0 1. So yeah, 1 0 1 I got. Now the next is 0 I want to derive. So 1 0 1 is there. Now the next turn of S. So I want to derive 0, and from S I can derive 0 or not, that I'll have to check. So now I'm checking my production rule. From S I can get 0. Yeah, so in first I can get 0. So I can take from S I am getting 0. Now here I got 0. Now I'll have to put again same as it is. 1 is there, 0 is there, 1 is there, 0 I already got right now. So 1 0 1 0, 1 0 1 0 is achieved now. Now the next turn is of 0. Now the next term which is remained to get derived is S. So from S I can get 0. Yeah, again say repeat the same step. From S I can get 0. Repeat the same step. So I'm repeating the same step again, and again I'm getting 0. Now there is nothing further to derive, and 1 0 1 double 0 I got. So this was my string I wanted to get, and at the end I got it. So these are my production rules. Using that I can derive it. So this is the string which I got. So here you can see that number of 0 are greater than number of 1. So this is what our language was there, that x belongs to 0 1 whole star, where number of 0 must be greater than number of 1s. So make the production rule. First of all, make the string, which are the strings which are possible. From that, use the logic, apply the logic and make the production rules. And after making the production rule, take any string which is satisfying your condition of the language and derive the string. So we are using recursive steps to derive it. So in this way we can derive. Here the next example which we are taking is language L, where 0 raised to I, 1 raised to j and 0 raised to k, where j is greater than I plus k. J is greater than I plus k. So what we'll have to take over here, that our language is there which is containing 0, 1 and 0's occurrence, where 1's occurrence is always greater than 0's occurrence, right? So suppose we are taking the example, j has to be greater than I plus k. So suppose we are taking m which is greater than 0, m which is greater than 0. Now for m greater than 0, we are taking that 0 raised to I, 1 raised to j, 0 raised to k. Now we'll have to decide that j has to be greater than I plus k. So one occurrence has to be greater than this and this, right? So we can consider that j has to be greater. Now it has to be greater than I plus k. So here instead of j we are taking 0 raised to I, 1 raised to, this has to be greater than I plus k. I plus k, power I plus k, it has to be greater, right? So we are taking I plus k plus something which is greater than 0, which is m, I plus k plus m. Now 0 raised to k, 0 raised to k. So here we can see that 0 raised to I, 0 raised to k, now 1 raised to I plus k plus m. So the occurrence of 1 will always be high. So this is my j, this is my j. So yeah, j is always, so if we are taking j is equal to I plus k plus m, so it is always greater than I plus k, means something, m is greater than 0, so it is always greater than I plus k. So this was my condition that I am satisfying. So I have taken that it is I plus k plus something, m, I don't know what is it, but it is greater than 0. So 1 raised to j, where j is greater than I plus k, I have proved, right? Now based on this I'll have to make the production rules. So first of all we are going to separate this. So 0 raised to I is there. Now if we are separating this one, so we can take what is common. So 0 raised to I, 1 raised to I is there. Now 1 raised to I plus k plus m. So if I am taking m, so I plus k plus m, so I then m. Now turn off k. So we can take 1 raised to k. Now 0 raised to k is there. So 0 raised to k. So we have just separated. I plus k plus m was there. So I have 1 raised to I have taken over here. 1 raised to k I have taken over here, and 1 raised to m I have taken in between. So these two are different statement. These two are different statement. This one is also different. So I can consider it as this as E, this as B, and this as C. Now was for these three statements I'll have to write the grammar, context free grammar. I'll have to make the production rules. Now here I have taken I, it can be 0, I can be 0 also, I can be greater than 0 also. So here I can write like that, I can be greater than or equal to 0. Now already I told you that 1 raised to j j has to be greater than I plus k. So I and k can be 0, but j has to be greater than that. So for making j bigger, we have taken a. So I plus k plus m. Now m is greater than 0. So m is greater than 0. Now I and k can be greater than 0 or equal to 0. It doesn't matter, right? So it can be equal to 0 also. So here I can take k is greater than or equal to 0. So now based on that, we'll have to make the context free grammar for this. So I can be greater than or equal to 0, k can be greater than or equal to 0. So suppose I is 0, k is 0, then there is no occurrence, so there has to be null, right? So first of all, we are deriving the statement for a. Now a is what is a given to us? A is 0 raised to I, 1 raised to I, where I is greater than or equal to 0. Now for this we'll have to make the expression. So we can take like from a. Now what it is containing? It is containing equal number of 0 and 1. So as many as 0 will occur, those many 1 will occur. So we can call it recursively 0a1. 0a1 we can say. So 0a1 always it will occur recursively. So once I have called 0a1, now a from a I can again call 0a1. So number of 0 and 1 both will increase at the same level. Now when I don't want to increase it, I just want to stop, a has to be null. So here I am taking null. So at one point there will be null. So 0 and 1 will remain. So rest of you can take as you want. Now a is equal to 0 raised to I, 1 raised to I, where I is greater than or equal to 0. So if suppose I is 0, then we can directly take from a null. But if it is not 0, then I can take from a 0a1. So multiple times you can call that. If 2 times 0, 2 times 1 is there. So I can take 0a1. Again from a I can take 0a1 and then make it null. So in this way a will work. Now the next turn of b. So for b, 1 raised to m, where m is greater than 0. So what we'll have to do for b? For b, 1 raised to m, where m is greater than 0, as already we told in starting that b is 1 raised to m, where we'll have to make it greater than 0. So 1 is going to occur for sure. Alright. So we can take it as from b we'll have to take, now 1 raised to m is there, where m is greater than 0. So we can say like m is greater than or equal to 1. So m will occur 1 times at least. So 1 will have occurrence of 1 time or more than 1 time, right? So it can occur from b I am getting 1, means if 1 time occurring then 1, if more than 1 time 1 is occurring then 1b, 1 or 1b. So if 1 time is occurring then simply from b1, but if multiple time is occurring 1b, 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 and at the end if you want to stop, put 1. So in this way I can get multiple times. Now the turn of c. So c is what? C is 1 raised to k, 0 raised to k. So c is equal to 1 raised to k, 0 raised to k, where k is greater than or equal to 0. So for this I'll have to take the same as a. It was 0 1, 0 raised to I, 1 raised to I. Here reverse is there, 1 raised to k, 0 raised to k. So same way I can write. Now here if I want to get multiple occurrence of 1 0, so I can write like 1 c 0 or null. So when we want to stop, only once we want to get 1 0, so I can take 1 c 0, then next time I can take from c null. So 1 0 will be there. So these are the production rules for getting 0 raised to I, 1 raised to j, 0 raised to k, where j is greater than or equal to I plus k. So that's why we have taken j is equal to I plus k plus m. So j will be always greater than I plus k, where m is greater than 0. So these are the production rule, that from S I am getting ABC, from A I am getting occurrence of 0 1, from B I am getting occurrence of 1, from C I am getting occurrence of 1 0. Now according to this, any string is given to me. So initially 0 1's occurrence is there, then 1's occurrence is there, then 1 0's occurrence is there. Now 0 1's occurrence and 1 0's occurrence can be 0, but 1 will occur at least one time, right? So from that, suppose we are taking any string, like 0 1 1 1 0. Now if we want this string to get occur, or if we are taking another string which is 0 1 1 1 1 0, right? So initially there will be occurrence of 0 1, occurrence of 0 1 which is A, then occurrence of 1 is B, and occurrence of 1 0 is C. So we'll have to separate our strings in 3 parts: 0 1's occurrence as A, 1's occurrence as B, and 1 0's occurrence as C, right? So A, B and C. So now we are starting with starting symbol, which is capital S. From S I am getting A, B and C. Now we are starting from the leftmost symbol, which is A. So from A, what I want to get derive? 0 1. From A I want 0 1. So see the production rule. From A I can get 0 1 or not? Yeah, I can get 0 1 from 0 A 1. So here I'll have to write from A 0 A 1. From A 0 A 1. Now I want 0 1 only one time. So I got 0 A 1. Now A, if I'm deriving again, then I can get 0 1 one more time. But here for A, I just want 0 1 one time only. So here A has to be null. So the derivation of A is from A get 0 A 1. Now from 0 A 1, A is there. From that derive null. So at the end we will get 0 and then 1. 0 and then 1. Now after 0 and 1, as they are terminals, we can't derive anything further, right? Now the next turn is for B. So for B, what we wanted to derive? For B we want to derive double 1, right? So is there any production for B in which I can derive multiple times B? Yeah, second statement is there in which I can derive multiple times B. So here I can take from B 1B, from B 1B. So here I am deriving from B I am taking 1B. Now in B I wanted 2 times 1. So here 1 times 1 is there. Now next time again I want to derive B 1 from B. So here from B single time I want 1. So is there any production which is deriving single time 1 only? Yeah, first statement. From B I am deriving 1. First statement is there. So I can take 1. So again from B I am deriving 1. So 1 as it is, 1 1. So here I can write it 1 1. So 0 1 1 1 I derived. Now the next turn, now 1 1 can't be derived further as they are terminals. Now next turn is for C. So from C, what I want to derive? From C I want to derive 1 0. So is there any production rule which is deriving 1 0? Yeah, first production rule. From C I am getting 1 C 0. So here I am going to use 1 C 0. Now from C further I want to derive something, but here 1 0 once only I wanted. So C has to be null. So is there any production which is deriving null? So C, yeah, C is deriving null. So I can take it from C, I can take null. So null means nothing. So ultimately at the end I will get 1 null 0. That means 1 0. So the string which I got is 0. So 0 then 1, so 1, next 1, 1, next 1, so here again 1, now 1, so 1, now 0, so 0. So yeah, match occurred. We got this string. Using this production rule, we derive the string. So this production rule is correct. These production rules are correct for the string. So it is satisfying the rule.